So in this exercise, we're presented with the circuit, and then we're asked to do some detective work to kind of work backwards to try to determine some values here. And the thing they're asking us to see if we can figure out is what is the value of this, or the values for this current source. We want to know first what the voltage drop is across it, and second, what is the current supplied from that current source. So let's see if we can work our way back to that. So the first thing we want to notice is, or look at, is this part of the circuit here. And so when we look at that, and put a green dot here. So to look at that, we notice that we have 1 amp going through this part of the circuit right here. And since the resistances are the same, that means the current going through this part has to be equal. So we're going to define this one as I8. So that means that I8 has got to be equal to 1 amp. So being that we know the current now, and we also know the resistance, we can use Ohm's law to determine what V8 is. So V8, in this case, using Ohm's law, we know that the current we just said was 1 amp, and the resistance we can see from the diagram is 8 ohms. So that means it is 8 volts. So V8 is 8 volts. So working further back, we now want to look at this section here. So when we look at that, we see that whatever current enters into here has to come out these 2 points here. Well, we know what the current is at those 2 points, right? We just determined that it's 1 amp going down each leg. So as we work our way back up, that has to equal to the total current coming through the blue section there. So if we mark this as, working on the blue section, we can then say, we'll call this current I4 to go along with the V4. So that being the case, I4 has got to equal to the total coming here and here. So we know that's 1 amp plus 1 amp, so that's going to be 2 amps. So now, knowing the total current going through that resistor, we can do like we did before, and we can determine what the voltage for V4 is, again using Ohm's law. That's going to be 2 amps times 4 ohms gives us 8 volts. So we know just about everything about the center section there, but one thing that we observe next is this is actually one node here, or one common point. And so this is one common point here as well. So that being the case, we can kind of divide this circuit into 3 parts, knowing that the voltage at this point is equal to the voltage at this point is equal to the voltage at this point. Well, the voltage at this point, we can just add up all the voltages going down from one point to the other. And so that being the case, we can do that. And so we'll say that voltage there is going to be equal to V4 plus V8. V8. And again, by voltage, I mean the voltage from here across to there. And so we know that V4 is 8 volts, and we know that V8 is 8 volts, so that gives us 16 volts. So being that we have 16 volts across the center, we should have 16 volts across here as well, and 16 volts across here. They all have to be equal because those three branches are in parallel. So now we want to look at the next branch here. If we look at this right here, we see that I5 travels through that 5 ohm resistor. And we also know that there's a 16 volt drop across that resistor. So that being the case, we can come back here and again use Ohm's law to determine what I5 is. I5 is, from Ohm's law, is voltage divided by resistance. So in this case, it's going to be V5 over I5. And again, we know V5 is 16 volts. And we know that the resistance, excuse me, this should be, said V over R. This is equal to the voltage V5 over the resistance 5. So that's equal to 16 volts over 5 ohms. Plug that into the calculator and we should get 3.2 amps. So this is important because now we can get to the point where we're trying to get. So we should notice now that, and let me clean this up here a little bit. So we should notice now that there are two paths, one going this way, one going this way, and that these two added together should give us IS. So that being the case, IS should equal to 2 amps plus 3.2 amps. That gives me 5.2 amps. So that's the value of the current source. And then the voltage across the source we already determined because we know the voltage across here, it's all the same, it's equal to 16 volts. So there's our two values, working backwards to get that.